Good morning. So I'm the oddball here. I'm a man and and an engineer, and I'm also from Quebec City. I live here, so I was grateful to ASHRAE for asking me to speak. I represent ASHRAE engineers to this conference. I had an 8-minute drive to come here, so I was quite fortunate. So today, let me tell you a little bit about myself. I've been a consultant and I've been in sales over the last 27 years in HVAC engineering in the built environment, which is where I've concentrated my efforts since graduating. And I want to tell you very briefly about some trends in technology efficiency and those darn humans in the built environment industry. You know, if it weren't for humans, we'd be so far ahead. So basically what I want to show you is, and I have a very quick presentation. These are the only real slide I have. And I want to show you a trend in our industry. And that is that since 1980, we know the beginning of the energy crisis, we've all become very aware of energy efficiency and then later on sustainability and renewable energy, those kind of things. But it started in 1980 with the energy crisis, the oil crisis. And we've all been an effort to reduce our gigajoules per square meters or BTUs per square foot. And then this red line here is what I call the market expectation. And by the year 2030, which Peter mentioned to us, is a target for ASHRAE and the Green Building Council, U.S. Green Building Council, and IESNA, which is the illumination engineers. So there's a whole bunch of people, and as well as the architects. We want by the year 2030 to have a working standard for net zero buildings. In other words, a building that would generate as much energy as it would consume. So its footprint would be zero, net zero. So that's the target. That's where we're heading. We're hoping that by 2030 we'll have a working standard, and we're doing very well going there. The problem is that since 1980 to about 2010, market expectations or the standards that ASHRAE would produce. So one of the things that ASHRAE does is we generate energy standards and air quality standards for buildings, and then every year, or every 3 years rather, our energy standards get more and more stringent, more strict as technology evolves. The big benefit was that we didn't have to change a whole lot of the things we did as engineers and architects, and the buildings would just become more efficient because technology was getting better. But around 2010, something happens. You know, the rate of improvement in energy efficiency in equipment kind of plateaued. It really slowed down. Okay, you look at before 2010, some of the improvements we've had. Direct digital controls replace pneumatics. There's a huge leap forward. We started doing condensing in boilers. I don't want to bore anybody here, but condensing boilers means that the best in class boiler, gas boiler, was around 82, 83, 84% efficiency, and then it jumped to 97% when we went condensing. Now from 97 to 100, there's not that much wiggle room, so it's not going to make a big impact here. The chillers that we used to consume something like 0.7, 0.8 kilowatts per ton of refrigeration. Now we're in the 0.3, 0.29 in some cases. We have magnetic bearings now, so we don't even have oil in our systems because our impellers and our turbines and our compressors are held in place by magnets. So we've done a lot to improve on our equipment. Problem is that these things are kind of slowing down. Once you get to 97% efficient in the condensing boiler, that's pretty much it. You're not gonna reinvent thermodynamics laws. You're as good as you're gonna get. So, in essence, we have as much technology as we can handle, and we've been taking advantage since 1980 of a technology surplus. So we didn't have to do a whole lot to our buildings, and they were still getting better and better every year. That's not true anymore. Now what we have is we have a technology deficit where the standards continue to improve, the requirements continue to improve, the expectations from clients continue to improve, but we don't have technological solutions we can point to make that happen. So what does that mean? It means that engineers and architects have to play better together. And as was discussed before, we don't usually train our students in engineering to necessarily play well with others. We We focus on science and technology, and we don't have a lot of project management courses. We don't have a lot of communication courses, leadership courses in engineering schools. And as a result, when they hit the marketplace, they are often ill prepared to deal with the new reality of the workplace. So I'm hoping that things are going to change. I'm doing my part, as we discussed earlier. My daughter is graduating next year in engineering, and I made sure that she was a very well-rounded person. She speaks 3 languages, and she's traveled the world. So I expect that she, as we discussed, we're all going to work for her in a few years. But I think she's the minority, honestly. I really think that Elizabeth is the minority of the engineers that are graduating. They're still very technology focused. And the diversity is increasing, but not great, and we're not retaining women as well. So there's some serious challenges. So let's talk about those challenges a little bit. And I've broken down into what I call the built environment challenge. So my industry's challenge. And the first one was we definitely need to focus on preparing the next generation of engineers, architects, technicians, and technologists to truly integrate the designs into cohesive solutions. So in other words, stop thinking about just my chiller or my pump, but really think, where does that fit into the entire building? So things like we need engineers to be able to go into architects' offices and say, you know what, that great big glass wall is fantastic. Hey, look, it's really great. It's a beautiful architectural gesture, but can we really afford it in the big scheme of things? Right? What about the building orientation? Can we turn the building so that we don't have so much solar gain to deal with? So those kinds of things need to be discussed more. And quite frankly, I deal with it every day. A lot of engineers don't have the skills to convince architects to do these kinds of things. And we need better salespeople in engineering. I can tell you, one of the reasons I moved to Quebec City from Ottawa was to work on the amphitheater. We have a brand new hockey rink, no NHL team, but we're sort of like Kevin Costner. If we build it, they will come. We're still waiting for it. But one of my roles was to influence design. So I was working on the owner side, and I was working with the designers and trying to change design. And one of the things that we did was very innovative, was to change the way we're going to ventilate the entire building, ventilating from the floor up, as opposed to the ceiling down and the roof down. And you'd be amazed at how hard I worked to convince people to do this. And I'm absolutely convinced that if someone like me wasn't on that team, it wouldn't have happened. And that building would be 30-40% less efficient, more costly to operate, and dustier, when they have tractor pulls, that kind of stuff. There's a whole bunch of things that we did. And then the math was there, the science was there. But then in the end, we still have to convince humans. And that's the part that we don't usually are very good at. And we need to do a better job at preparing the next generation. We need to focus right now. And I'm so happy to hear, Judy, you're working with high schools, and I think we need to do this a lot more. In fact, one of the things I do for ASH right now, I'm not so involved with society anymore. I was quite a bit, but now what I try to do is I visit high schools. I go talk to kids in grades 6, 7, 8, middle school rather, and try to get them excited about careers in engineering. It's a fertile ground. Before that, they don't know enough. After that, they know everything. So grade 6, 7, 8 is a really nice time to talking about STEM, science, technology, engineering, math. The next thing we need to do in our field is we can't forget the people that are working today. Mentoring, more training. We need to look at training the people that are actually working today, and then improve their working methods. They need to play better with others, and that's difficult to do. And finally, we need to educate our clients and our end users and our occupants and our owners to change the way they do business, because it starts with them. In fact, we could give up on the first 2 if we could do the third one really well. Then everything else will just fall into place. If we could somehow change the way owners hire engineers and architects, and then change the way that they get them to work on projects, then the problem would eventually solve itself. But that's very difficult. You mentioned how difficult it is to get engineers to change. I think owners are worse. It's much harder, because most owners, and I hope nobody here manages facilities. I don't want to insult anybody, but they tend to be older. And a lot of them are thinking, I got 5, 6 years of this. I'm working on this project. I don't really want to relearn a new technology before I retire. But that happens all the time. There's always like an old person there not wanting to learn something, and then they're pumping the brakes on innovation. So we need to educate our end users. So let's turn to professional associations and what they need to do. Well, continuing education has to be a focus. That can't change. Something as a service that professionals internally are very bad at. We talked about mentoring today. It's difficult to get professional engineers, professional scientists to mentor younger technicians because we're not set up that way. We don't have fees to do this in a lot of cases. We can't afford to do it. So we turn to associations to do that kind of work. We need to work better with others and other associations. One of the things that ASHRAE has been doing is that we've worked with the architects, we've worked with other associations. We've integrated with an air quality association recently. We want to work with the illuminating engineers as well. So we're working better with others and with people in Europe and the Far East. So this has to happen as well because we can no longer just look at our problems as being just solved by ourselves. And then the third one that I see is reach out to attract members that are atypical from our society. So other than practitioners. So we have to draw in owners and architects, and in our case, and electrical engineers and civil engineers and structural engineers, people who have never cared about HVAC or HVAC or the mechanical or electrical portions of a building. They have to get interested in it because they have to participate in that new problem of sustainability. So those will be the new challenges, I think, of where we're sitting, and I think that sits in very well with the kinds of stuff you guys mentioned. So we look forward to some questions.
Yes, absolutely. Thanks.